Hi all. So in this video, we'll cover exploratory data analysis, which is one of the topic for class 12. And primarily here we'll focus on univariate and multivariate analysis, as well as data cleaning uh, techniques. And under each of these categories, we'll look at some of the commonly used tools that can help us do it. So before we move further into this, um, what is exploratory data analysis, right? So exploratory data analysis is typically the first process, right, or first step before you start into the other detailed part of your modeling journey, right? So before you get into and start actually looking at your model building, or more advanced feature engineering, or some of the uh, steps, right, related with your modeling, you try and look at data, right, and try and figure it out, right, what kind of data set it is, and do we need to do some kind of uh, post processing or transformation so that it becomes suitable for your analysis. So in that sense, we'll start with something that we call univariate analysis, right? Univariate analysis is typically when in your data set you are having say multiple variables. Here, before you start looking at, right, more than one of those variables together, you first look at a single variable at a time, right, and then you try and figure it out, try and understand the basic structure, look at how you can summarize it, and then try and plot it, and try and figure it out if it is having some sort of issues at the independent at the single variable level itself, right? So here basically some of those central tendency measures, primarily looking at mean, median, or mode, could be helpful. um, then we can look at the spread using either of range, variance, or standard deviation, and then you can analyze the distribution plot itself to see if it is having skew or kurtosis, right? So skewness and kurtosis are actually the terms associated with shape of the distribution. We will actually try and cover this in little more detail if your syllabus really needed it. But let us come to the more common and more commonly used step, right, which is how you can visualize your single variables, right? So some of the well-known techniques are primarily about using bar plots or box plots or histograms, right? um, Here if you see your box plot, for example, right? So say if you are actually looking at height of all the students in a class, right? And if you look at the average height, and a spread, right, on either side, you will actually get something that we call box plot. So here you can look at the the middle red line, and then you look at the two horizontal bars, right? So uh, by looking at it, you can see that how far from mean, right, the data sets are, right, and it gives you some idea about its spread. In terms of histogram, you can actually look at the frequency distribution versus some range of it. So you divide your data set into some range. For example, if your marks are like 0 to 100, you group them, and then you look at frequency in those groups, right? So say for example 0 to 10, 10 to 20, and that way. So by looking at histogram and box plot, you can get some idea about spread and central tendency of data, and then you can move on where you look at more than one variable together, right? So uh, very next thing is looking at two variables together, and there actually, you can look at, for example, correlation analysis, right? So that can tell you the relationship between two variables. In one of our previous you know videos, we talked about how you can actually calculate correlation, and what exactly it is when it is from -1 to 1, right? Perfectly correlated on positive side as +1, not at all correlated as 0, and a similar mirror replica of +1 as -1 when they are inversely correlated. Scatter plots can be used for visualizing uh, some of these quantitative variables, where across two axes you can actually just put all the data point and try and see if there is some kind of trend, or they are actually all over the place, right? Cross tabulation, if these are categorical variables, so variables could be numeric, some numbers, or could be categorical. For example, if you are talking about say type of fruits, right? So those could be different categories, and categories can be then grouped by unique or count and some of those things to get higher level features. Contour plot is another interesting study, and if you are actually trying to find out, right, how some of these things can be analyzed, right? Say for example, if you are looking at your study hours and marks obtained, right? So if you look at pair plot, right? So here basically what you are doing is uh, you are looking at uh, you know uh, two variables, right, in one go, and then you see whether actually there is some trend or not, right? So if you see, for example, uh, you know some of these data sets, right, are evenly spread. Some of these are actually having certain kind of trend. What does that mean is actually um, uh, the data sets are either actually more oriented uh, on one part of the plot, right? So looking at this can give you some idea. um, Contour plot, this could be actually when you want to do three-dimensional one, right? So you can have say for example two independent axes and then one dependent axis, and here you can actually look at more than two variables uh, together to see any kind of relationship out there, right? So uh, this could be important for visualizing relationship between two or more variables. This is just actually one typical example that you see. Now, once you have looked at your univariate and multivariate analysis, the next step could be that based on whatever you have observed, right? Do you need to kind of do next level of data cleaning, right? And in terms of data cleaning, we'll look at some of the common steps. So one of the things could be that you are having missing data, right? So because of variety of uh, data capture, process related issues, or in many cases null availability or data, or that particular data point is say not applicable, because of variety of reasons, right? You might see that at several point several of those data points are uh, not available, right? And there are several strategies to sort of fix this depending on the use case. Some of the very common one are, you can take actually mean. So you can actually take, because typically you can assume that missing data points are more closer to mean, median, or mode. Or you can use advanced method for imputation. So imputation could be more like you can look at some other variables, right, on which this particular variable is having some kind of dependency, right? and then you can fit one of the linear regression or some other similar techniques um, to sort of impute it, right? Then many a times you'll be having you know duplicate linkage, right? So that you can actually identify and remove. Dealing with outlier is always actually a bigger issue. So far we have been talking about ZS code, which tells that how many standard deviation away from mean this particular data point is, or interquartile range, right? You can make a decision to um, sort of not at all use that particular data point, right? So say anything about three standard deviation or interquartile range beyond certain thresholds, you can actually define some threshold based on your exploratory data analysis that you have seen, either in a box plot or a scatter plot or some of the other variations, and then actually you can make a decision of dealing with outliers. Fourth one could be standardization and normalization, right? So these are more about how you can scale data, because many a time different features, right, could have um, different range, right? So say for example, if you are talking about some um, some common feature, right, about individuals, and then say those features are, say, some physical characteristics, right? So how long they are, what is their weight, right? You know Then for example, how much they are, right? So say if you are looking at these three numbers, typically your weight and height, right, will be in some well defined range. For your say for example, height could be say 4 feet to 7 feet, somewhere in between. Your weight could be say 30 kg to maybe 150 kg or 200 kg in some cases. But your income uh, could be few thousand rupees to several billion rupees, depending on whom you are going to talk about. So few billion will be actually very big number, while the kgs or the fits, right, for individuals could be very small. So many a time, even to make sense of it and as well as to standardize, what we do is for each of these columns we find out standard deviation, and then we simply apply the formula of x minus mu by sigma. So basically you will see that how many standard deviation away from mean this particular point is, and in that sense you get actually a lot of your number, because large part of your number for normal distribution are going to be within 3 standard deviation away. So you can expect that most of your number, 97, 98, 99 percent of your numbers will be between -3 and 3. So that will be much easier to manage. Another important point here could be that if there are different units, what to do. So the if you are capturing say certain characteristics, say for example distance covered, right, across say uh, some variation. So if you capture some of them in kilometer and some of them in meter, uh, if as long as they are actually relatable, right? Say for example, distance covered by car but versus distance covered by motorcycle. So if you have distance covered, by motorcycle in meter and distance covered by car in kilometer, those numbers will not be comparable, right? So you need to kind of convert them into common unit, either meter or kilometer, before you apply normalization. So that will be actually sort of a standardization on need basis, where you look at the unit of your data set across features or across variable, and then you make right kind of judgment, right? Some of them might require you to bring them in same unit, some of them might not be. Then actually there could be data format related issues, or a different kind of data set. Data format issue could be typically coming with say date, right? So many a time there are so many different formats: year, month, date, then date, month, year. Then for year, someone is using 4y, right? So if this is date related, you would like to kind of standardize and put it into one format. Your data capture process might be so that sometimes people are describing it in numbers, sometimes people are describing it in text. So you have to look at it and kind of convert them into a number or string or whatever is appropriate, so that you are dealing with only one type of data set, or actually make right kind of adjustment so that your tools can handle it better. So just to summarize, once you come to data cleaning, handling missing data, removing duplicates, dealing with outliers, standardization, normalization, and handling inconsistent data. These will be typical common steps. And out of these, handling missing data and dealing with outliers and standardization, normalizations are more important than others. Okay, so so far we actually started talking about the importance of EDA. Then we briefly talked what univariate analysis will be. Then we talked about multivariate analysis, and then we talked about a couple of tools around that, and finally we are talking about how you can do data cleaning, which is very important, right? Now we look at some of the sample questions asked in your exam, right? So it could be more like you'll be having MCQs where actually there could be a few line of question like you need to check the relationship between the two variables, right? So which graph or which tool you will use, right? So as you know, for two variables, histogram and box will not be, so you have to use a pair plot, right? The second question is saying that if you have to check for outliers, right? Which one will be best? As you know, box plot will give you a spread, right? So histogram and pair plot will not be. Box plot will give you the easily visualization sort of about outliers, right? For multivariate, as you see, contours could be better suited. Uh, for univariate, right? If you are looking at a scatter plot or histogram, both can be used. Data cleaning, as you saw, right? Removing duplicates, removing outliers, all of the above. So in this case, you have to choose all of the above, right? Because both could be part of data cleaning step. Then some of that requires you to describe in say at least more than 100 words, right? So here it is talking about difference between univariate and multivariate. Give some examples. So you can define what univariate is, what multivariate is, then talk about some of the box plot, histogram, a scatter plot, right? Pair plot, uh, whatever we talked about, right? What are the ways of handling missing data, right? So as you saw, you can actually replace that by mean, median, mode, right? Or you can actually find out higher order imputation like linear regression, right? uh, then some of the method for univariate analysis, right? So you can do histogram, uh, box plot, right? A scatter plot, cleaning raw data. So cleaning raw data is again actually kind of format related things, right? So solve formatting, solve mix formats, right? Those kind of things. The issue here is what problems can outliers cause, right? So you have to describe that in more than 200 words. If you have actually seen my last video, right, we are talking about how to find outliers, right? And we also talked about, that out of some of the central tendencies measure that you are having, mean, median, mode, which of those actually captures the essence of outlier or handle outliers, better, right? So the issue here is what problem an outlier may cause, right? So what happens? You look at, um, even if you're in exploratory data analysis, when you are doing a standardization, what you are doing? In your standardization, you are taking the difference from mean, right, about individual data point, and then you are dividing that by a standard deviation. Now, both your mean and standard deviation can change drastically with just a few outlier data set that you are having, right? So in a way, even your standardized data, right, could be lot different because your overall spread could be very high. Remember, when you are having um, all your data point closer to mean, then your spread is less, right? So your variance is low. Whenever you are having very high variance, that's always going to cause issues, because just a few data points can change actually everything, and those data points might be there because of some, say, data capture issue, or some kind of, some data scientists might have made actually some mistake while they are trying to modify many of those kind of things, right? So that's why it is very very important that you identify outliers, because just a few data points can actually um, impact your overall modeling, right? Why should irrelevant observation be removed from the data? So irrelevant observation, should be removed, because otherwise what will happen, right? They are not important, right? uh, for your overall behavior, right? So many a time when you are looking at correlation, when you are looking at variance, when you are looking at a standard deviation, right? Many a time, if you are having irrelevant observations which are actually not needed, right, then those things can uh, uh, you know impact your modeling outcome in a negative way. So that's why you don't need, right? Unsupervised learning for EDA. So exactly what we are doing here, we can actually look at exploratory data analysis, right? And we can actually from there on say we can group data automatically, right? Based on how far they are, right? uh, by combining, so another thing is when we are looking at correlation, right? um, when two variables are perfectly correlated, you don't need both of them together, right? uh, so you can actually, uh, in later part of the video, you will see all likes, multicollinearity and things like that, right? So these actually areas, right, um, could be helpful from area perspective. Great. Um, so the next thing is actually, can you analyze, right? Iris data set is, a kind of a very well curated classifier sort of data set, where, based on sepal length, sepal width, and petal length and petal width, for about 150 different data set, people have, put some kind of classes out there, right? And it is used actually as a very very common hello world example. The ask here is, from your project perspective, how you can use some of the univariate analysis, right, for creating a scatter plot for these individual field, right? So I have just pasted the, you know scatter plot part of it, uh, for petal length, petal width, and sepal length, and petal length, petal width, and uh, sepal length and sepal width, right? We'll actually get into Python, you know, as editor, and we'll show how we are actually doing it. Okay, so I can just help you walk through what we have done. So first 4 5 lines, the one that I've highlighted here, we have we have imported relevant libraries. So Cborn is a library that is used for uh, you know better or more involved visualization. Matplotlib is very very common. So we are actually taking pyplot part of it and importing it as PLT, and then actually Iris data set is available inside sklearn package. So we are actually importing uh, node iris from there, and Panda is actually general purpose uh, to packaging sklearn, right? Loading is pretty much the common syntax, right? So we simply call load iris, and you can see that your iris data set is uh, populated. So you can check what iris is, right? So if you see, it is having information about all the individual petal length, petal width, sepal length, sepal width, right? And then it is having target variable, right? From 0 till 3. So basically four kind of uh, targets. So if you see here, uh, iris target, right? So you see all the uh, you know uh, individual targets, right? Then we have converted this at the next slide, right, into the data part of it, right, into a data frame. So that's where actually you can look at iris df. You can actually try and see the basic description out there. So across these four variables, you can see the you know quantile, mean, max related details, and then we are actually setting up the visualization part. So this is actually setting up the column from data, and then the visualization. Where actually for each of these features, we have simply called SNS as scatter plot to visualize it, right? So you can see that in diagram. Okay, so we'll actually um, just give us a second. Yeah. So we actually covered, univariate and multivariate. Then we talked about some of the commonly used data cleansing, and hope you enjoyed it. We'll actually in next lecture or in next video, we'll cover actually your regression related details, and what kind of questions, right, you can expect in your board exam.